Ladies and gentlemen, good day and welcome to Grade 10 Technical Sciences Control Test March 2024 Memo discussion. And I am Mr. Nambane. I will be taking you through because now we have colleagues committed in other uh, activities of the department, well done functions, and all sorts of nice things happening to our teachers. Ladies and gentlemen, however, I need to inform you that the recording of this session will be available on Nambane Academy on YouTube. The link has been shared and kindly complete now the register. Ladies and gentlemen, I don't intend on keeping you long. The questions in this paper were straightforward. However, any other inputs will be taken for the purpose of discussion thereof. Ladies and gentlemen, without wasting any time, let's go straight into it. With question one, ladies and gentlemen, all the given options are correct. That means in question one, there is nothing that is now changing. So everything remains the same. We looked into them again to verify everything seems to be correct. If there's anything, kindly feel free to indicate that. For question two, it says now consider the table below and answer the questions that follow. And in the table, we are given different SI units and weights, and then we must refer to the table in order for us to answer. Ladies and gentlemen, at 2.1, it says, write down the correct SI unit for mass. 1 mark, the correct answer is kg. 2.2, write down the symbol for ohms. 1 mark, it's that omega sign, and at 2.2. 2.3, ladies and gentlemen, convert the following 231 20 megahertz to hertz. That will be now 20 multiplied by 10 to power 6 hertz. Ladies and gentlemen, it must go together with the SI unit. 232, convert 500 grams to kg. It must be 0.5 kg for 2 marks, ladies and gentlemen. At 2.4, write down a suitable unit for measuring energy. The answer there is G for joules, ladies and gentlemen, 1 mark. 2.5, convert 500 microcoulombs to coulombs and give your answer in scientific notation, ladies and gentlemen. 1 mark for saying 0.005 coulombs, and now 2 marks for writing it in the form of a scientific notation. That is now 5 multiplied by 10 to negative 6 coulombs, ladies and gentlemen. And that's basically it with question number 2. I will pause a little bit and check if there are any questions relating to that, but unfortunately enough, there is nothing. Then it means we can basically go to question 3. Now with question 3, study the diagram below and answer the questions that follow. At 3.1, calculate the area of the field. For the area of the field, ladies and gentlemen, is area length multiplied by breadth, 1 mark for the correct formula. The substitution of 85 meters, 1 mark. Substitution of 35, 1 mark. And the answer, ladies and gentlemen, with the correct SI unit, 1 mark. And the answer should be 2,975 meter squared. 3.2, it cost a school 1 rand 20 per square meter to mow the lawn of the field. calculate the total cost to mow the entire field. So it is now 2975 multiplied by 120 is giving us something like 3,570 rands to mow the entire field. However, ladies and gentlemen, it is only fair to say let's have here now a positive. Let's have here positive marking. The reason for having positive marking, ladies and gentlemen, is now the skill that we want to assess is that learners are able to calculate area and understand that we need to multiply the area with now what? With tariff in order for us to get the entire amount that is needed now to mow the entire field. Ladies and gentlemen, at 3.3, while the caretaker was mowing the lawn, grade 10 learners recorded the following results. Time in hours and temperature in degrees Celsius. Identify the dependent variable. Dependent variable, ladies and gentlemen, is temperature. What is the relationship between time and temperature? Time is directly proportional to temperature. For time is directly proportional 1 mark. It's part marking, ladies and gentlemen. To temperature is now another mark. Excuse me. As the time increases 1 mark, the temperature also increases 1 mark. So when we mark this, ladies and gentlemen, let's just be considerate in terms of the language that the learners are referring to. If you sense that the learner is actually referring that if time increases, the temperature increases, but not in so many ways, you will be in a position, ladies and gentlemen, of awarding 2 marks. And that's basically it with question number 3. So I will pause a little bit just to allow each and every one of us to actually give any further inputs on question 1, 2, and 3. Thank you very much, ladies and gentlemen. I got a request and a question from Donald Ndlalankulu, all the way from Bethlehem Comprehensive, and the question is, good afternoon, Mr. Nambani. In 3.1, if the learner got the answer correct and omitted the SI unit, do we give a mark for the response? Unfortunately, Mr. Ndlalankulu, we cannot award a mark. For us to award a mark, it must be with the SI unit. So if it does not have the correct SI unit, unfortunately, we cannot award a mark. Ladies and gentlemen, I think that's all that I got from question 3. Let's now quickly go to question 4. Now in question 4, 3 forces are acting simultaneously on an object as shown in the diagram below. Define the resultant vector. Resultant vector is defined as a physical quantity that has the same effect as two or more vectors. Colleagues, we can accept that one that says it is the sum of all vectors. We can accept that and also give it 2 marks. So at 4.1, resultant vector is a physical quantity that has the same effect as two or more vectors. And ladies and gentlemen, I must emphasize this is now 2 or 0. At 4.2, use a scale of 10 millimeters to 1 Newton to determine the resultant force of the three forces graphically by means of construction, ladies and gentlemen. Now, checking the scale given, ladies and gentlemen, we are going to benefit our learners here, provided that they are using the correct direction as well as the correct magnitudes. Why do I say so? The scale of 10 millimeters into 1 Newton is very, very small. So you'll be getting smaller graphical representation. However, other learners will just use their thinking and not use the scale. Let's benefit them as well, ladies and gentlemen, because when you consider it, when you want to actually draw it using the scale, it becomes very, very, very small. So let's be considerate in terms of that. Now, how are we going to mark this 4.2? There's a marking criteria here, ladies and gentlemen. It says correct measurements and direction of the two forward components, 1 mark. That means now for the first 10 Newton and for the second 10 Newton, they must be in the same direction for us to award a mark. Correct measurement and direction for the backward force or the backward component, that is now the 10 Newton, that is now going to the left, 1 mark. Head to tail method has been correctly applied to determine the resultant and show the resultant. So they must indicate where the resultant is. And for that, ladies and gentlemen, 1 mark. All components in R have applicable labels. So remember, they must now indicate which one is 10 in terms of direction, which one is 10 in terms of direction, and also indicate the direction of the resultant, ladies and gentlemen. So this is how we are going to mark 4.2. At 4.3, define the term equilibrium. Equilibrium is a force equal to but opposite to the resultant sum of vector forces. In simple terms, equilibrium is a force that is equal to the resultant but in an opposite direction. Ladies and gentlemen, let's not be too harsh in marking this one. What is important is it is a force that is equal, let's underline, but now in an opposite direction to the resultant. If you have these two key critical words, kindly award marks. It is equal but opposite direction to the resultant force. It is true. We advise our learners to write definitions as per terms and definition, exam guidelines, but grade 10s do not have the exam guidelines, ladies and gentlemen. So they are relying on what you are giving them. So if it happens that they forget and mix up the words in so many ways, kindly check if all the critical underlined words are there. Equilibrium is a force. That one is known. But what is critical? It is a force that is equal to the resultant force but acts in an opposite direction. If the context is correct, ladies and gentlemen, if the context is right, kindly award the learners those marks. 4.4, Write down the magnitude and the direction of the equilibrium. Ladies and gentlemen, it must be 10 newtons, 1 Mach. That is how we should actually mark it. 1 Mach for 10. And then for any direction that indicates it is now in an opposite direction, backward, left or west, you can award another mark. Let's not make it 2 or 0, ladies and gentlemen. Let's make it now a part marking. The important part of part marking is that at least they will get now 10 correct, and also the direction now correct, ladies and gentlemen. So let's make it now part marking. 1 Mach 10 Newton, and then 1 Mach for the direction. 4.5, the vectors are now all in the same direction to the left. How will it affect the following physical quantities? Choose increase, decrease, or remain the same. Now all the three vectors, ladies and gentlemen, are in the same direction as to the left. 451, how will this now affect the resultant vector? The resultant vector is going to increase, ladies and gentlemen. How will this now affect the equilibrium? The equilibrium is going to decrease at 452. And those are now 2 marks. At 4.6, power is the rate at which work is done. And the formula is given, P is equals to W over T. And it says now, if 400 joules is used to over a period of 2 minutes to move a box to the right, calculate the rate at which work is done. We gave them the formula, ladies and gentlemen. We will award a mark for the formula as well. Because the formula was not included in the formula sheet, so we opted to say, let's give the formula to them. So by choosing that correct formula, it means now what? They will get 1 mark. Substitution of 400 joules, 1 mark. Substitution and conversion of 2 minutes to seconds of 120, 1 mark. If they substitute a 2 there, ladies and gentlemen, no mark, unfortunately. Then the final answer, 3,3 watts with the correct SI unit, ladies and gentlemen. And that is the practice that we should emphasize, to say you only get a mark for the final answer, provided, ladies and gentlemen, what? Provided that the final answer has the correct SI unit. If not, there's no mark. Rather penalize now, ladies and gentlemen, such that all these misconceptions, errors can be corrected for us when moving forward. Ladies and gentlemen, that is all with now question 4. I will pause a little bit and allow you to raise hands and give me any inputs or questions that relates to question number 4. Thank you very much, ladies and gentlemen. I don't see any hands. I don't see anything on the chat. We can easily now go to question 5. At question 5, it says a learner is participating in the Free State Athletics Championship in 2024. He is a sprinter that participates in both 100 meters and 400-meter races. Every race starts from rest at the starting point A. Study the diagram below and answer the questions that follow. 5.1 Differentiate between distance and displacement. In actual essence, this question is asking learners to give us a definition of what is a distance and a definition of what is a displacement. Distance is the length of the path between 2 points, 2 marks. Displacement is the length of the shortest line between 2 points in a particular direction, and that will also be 2 marks also, ladies and gentlemen. Furthermore, calculate the total distance of one lap. The total distance of one lap, ladies and gentlemen, is 400 meters. AB 100, DC 100, and these other two sides must now be completed in terms of 100, 100. That will give you now 400 meters. Calculate or write down the magnitude of the displacement for one lap. That is 0, ladies and gentlemen. Because remember, for one lap you start at A and you end up at A, so it means your displacement in that position should be now 0, 1 mark. 5.4 The learner completes one lap in 57.4 seconds. Calculate the learner's speed. Now, why is it saying positive marking, ladies and gentlemen? Remember, 5.2 was asking about the total distance. So if that learner got an incorrect answer at 5.2, let's say 200 meters, and that learner uses the 200 meters in 5.4, we continue marking because we agreed it is positive marking. So 1 mark for the formula, either in words or symbols. And then now 400 divided by 57.4, 1 mark for both of them, ladies and gentlemen. And the final answer with the correct SI unit, that is now 6,96 meters per second. The diagram below represents an extract from the above athletics track. At 5.5, define the term velocity. Velocity is defined as the rate of change of displacement. Ladies and gentlemen, it is also something like 2 or 0 on this one. Calculate the velocity of the learner over 100 meters. Now, over 100 meters, ladies and gentlemen, velocity is equals to displacement over time, 1 mark, 100 divided by 57.4, 1 mark, and the final answer is 1,74 meters per second. 5.7, define the term acceleration. Acceleration is the rate of change of velocity. It is also 2 or 0, ladies and gentlemen. Now at 5.8, the learner's average acceleration in 100-meter race is equal to 0,13 meters per second squared. Determine by calculation if the learner will break the current world record. Sorry about that, ladies and gentlemen. It was a small glitch with the network. Now let's start at 5.8. The learner's average acceleration in 100-meter race is equal to 0.13 meters per second squared. Determine by calculation if the learner will break the current world record of 9.558 seconds set by Usain Bolt in 2009. So the expectation, ladies and gentlemen, is they must calculate time and check the time that now this learner completes 100 meters versus the one of Mr. Usain Bolt. Now 1 mark for the correct formula, 1 mark for the substitution of acceleration 0.13 and the velocity, ladies and gentlemen, from 5.6. So just check if the learner took that velocity of 5.6 and substituted into 5.8. We continue marking, hence it is positive marking. The final answer, ladies and gentlemen, is t is equals to 13.83 seconds. Now, the learner must conclude because the question was, will the learner break the record or not? So the answer there should be no, the learner will not break the world record. Now, ladies and gentlemen, what happens in such a situation that the learner uses an incorrect answer from 5.6 and finds that now the time is below the one of Usain Bolt? And the answer of the learner is yes. Ladies and gentlemen, we can only give 1 mark for the formula, 1 mark for the substitution, and 1 mark for the correct final answer according to the answer that the learner got at 5.6. But we will not give this mark of no. Then it means it will be 3 out of 4. Ladies and gentlemen, and that is now everything under question 5. Allow me to pause a little bit, check the comments on Facebook, not Facebook, on YouTube, and while you are raising your hands in this platform. Thank you very much, ladies and gentlemen. Thank you very much, ladies and gentlemen. I do not see any hands or any comments on the YouTube channel, so it basically means we can go straight to question 6. Consider a car towing a trailer along a horizontal road. Study the diagram below and answer the questions that follow. Define the term force. Ladies and gentlemen, it is 2 or 0, but if the learner just gives us it is a push or a pull from grade 9, let's accept and give 2 marks. The word object can be now in brackets because it's not necessarily important to say of an object. It can be a push or a pull that is sufficient for us to give 2 marks. At 6.2, identify 3 contact forces and 1 non-contact force. Contact force, any of the 3, ladies and gentlemen. Frictional force or friction, force applied, normal force, and tension. Any of the 3, ladies and gentlemen, we will award 3 marks. The only non-contact force in this instance is force of gravity or gravitational force or Fg. That is now the only non-contact force that we have. So ladies and gentlemen, that is now 4 out of 4 for 6.2. The letter T represents tension. Define the term tension. It is 2 marks at 6.3, a force acting in a string or a rope. If you get anything funny, ladies and gentlemen, kindly don't award. Because for us to refer to tension, it means the string must be there or a rope must be there. 6.4, draw a free body diagram of all the forces acting on the trailer. For us to award a mark, all the forces must start from the object moving outwards. 2, the forces must have an arrowhead, indicate the direction. 3, it must have a label, ladies and gentlemen. If you see there's an arrow but no label, we don't award a mark, we penalize. If we are expecting 4 forces and the learner gives us 5, we penalize for 1 extra force. So 1 mark for normal force, 1 mark for tension, 1 mark for FG, 1 mark for FF, which is now frictional force. All the acceptable reasons includes a learner can write Fn or N or normal force, T or tension or just 10 because it is given as 10 newtons, W or Fg weight or gravitational force, F, Fk friction or 20 because the friction was given as 20 newtons. So that at 6.4 it will give us 4 marks. 6.5, calculate the gravitational force acting on the trailer. So W is equals to mg, 1 mark, 750 multiplied by 9.8, 1 mark, that is now for the entire substitution. Final answer 7350 newtons with the correct SI unit. But because the question did not say calculate the magnitude, it said calculate the gravitational force. We are also interested in the direction of the gravitational force. So the learners, ladies and gentlemen, for us to award the final mark, it must be 7350 newtons downwards. Very, very, very important, ladies and gentlemen. 6.6, differentiate between mass and weight. Ladies and gentlemen, we are looking for 2. But however, we have 1, 2, 3, 1, 2, 3 differences. So any one that the learner can use, 1 for mass, 1 for weight. Then you give that 2 marks. Sorry. Now for mass is measured in kg, 1 mark. Weight is measured in newtons, 1 mark. Ladies and gentlemen, they can write it in weights, kilograms or newtons. It is still fine. It is the difference between the two. They can use a definition also to differentiate between the two. The amount of matter in the body and weight, it is the gravitational force the earth exerts on an object on or near its surface. They can compare in terms of the physical quantity, whether it's a scalar or a vector quantity. So mass is a scalar, 1 mark, and then weight is a vector, 1 mark. Now, ladies and gentlemen, the difference given by the learner. The learner cannot say unit kg, and the difference for weight, the learner says vector. No. Weight or the difference must comprehend each other. If it's comparing in terms of units, then it must be the unit of mass against the unit of weight. If it is the definition of mass, it must be the definition of mass against the definition of weight. You cannot have saying it's a scalar and then weight unit and then you give 2 marks. No, the differentiation factor must be the same for mass and weight. 6.7, which one of the car has the smallest weight? Write only the car or the trailer. Ladies and gentlemen, straightforward is the trailer for 1 mark. 6.8, calculate the resultant force acting on the car. F net is equals to F1 plus F2 plus F3, 1 mark. Substitution of 100 newtons, 1 mark. We only give the mark 4, 10 and 20 provided that the correct direction was used. So kindly check the direction that the learner is using, because you'll find other learners saying -100 plus 20 plus 10, we will also award a mark. Because the negative, ladies and gentlemen, it only indicates the choice of direction that the learner has used. Ladies and gentlemen, 1 mark for both substitution of -20 and -10 newtons. Final answer, 70 newtons to the left. So direction, very, important, ladies and gentlemen. At 6.9, what is the effect of an increase in the magnitude of friction on the net force? Right, only increase, decrease, or remain the same. So obviously, ladies and gentlemen, if we increase now the frictional force, it means our net force will decrease. 1 mark. 610, determine the magnitude of the resultant force when the car and the trailer are at rest. They need to understand, ladies and gentlemen, when the car and the trailer are at rest, it means the net force should be equals to 0 Newton. Somebody is going to ask me that, Nambani, do we need now for learners to say 0 Newton? Ladies and gentlemen, we can put the Newton into a bracket. We must just say 0. It is fine. We can award a mark. Ladies and gentlemen, and the total of this paper, it is now 100 marks. And I'm going to check also on YouTube for comments. I have one here from Mariska. It says, say at 4.52. 452, let's go to 452. 452. Should the answer not also be increased if the resultant increases? The equilibrium must also increase since the magnitude of the two must be equal. Sorry. I thought of it, Mariska, but I thought I will add it into the addendum to discuss it a little bit with the examiners, because I also thought it should be the same as that one, but in an opposite direction. Maybe they assigned the negative to the magnitude. I really wanted now to think of it deeper. So for now, let's keep it as is, but however, I will discuss and send the addendum later. Thank you very much. And in the meeting, ladies and gentlemen, I don't see any hands or comments. However, I'm just going to request that one of you say something. Let's start with Memoralani. Comments, please.
Good afternoon, colleagues.
Afternoon, ma'am.
Mr. No, I have no comments on it. I think the paper was. I would love to say fair, but yeah, I think this is what our learners need to get used to the standard and how we do things in technical sciences in grade 10. Thank you.
Thank,
Happy miking.
thank you very much, Memoralani. Ladies and gentlemen, that is true. The reason why we opted to have common papers is to set the tone and standard throughout. And let's ensure that our learners are always exposed to these papers. I have schools that did not write this paper for any other reason, but please, let's ensure that we expose them to this kind of papers, because at least They assist in terms of quality marking, they assist in terms of quality assessment. Ladies and gentlemen, uh, let me also take an opportunity to thank the examiners of this paper in no particular order. Me Sobane from Iketsetseng, thank you very much. Me Musa from Morena Mokopela, thank you very much. Me Bezedin Hout from HTS Louis Bota, and Me Keke Molefe from Lenakeng. Colleagues, I was just a middleman trying to ensure that everything is done the right way. And with that being said, thank you very much, ladies and gentlemen. Remember, kindly complete the register now. If you complete it after an hour or tomorrow, Auditor General will not be in a position of assisting you or accepting the register. The only reason why I'm already sending it is because we need actually to complete it during the session. So, ladies and gentlemen, please complete the register, and it is the only evidence, Mem Nyaman, that you were here in this particular meeting. If I visit your school and start moderating and I find deviations, I will not say I saw you in the meeting. I will just say, but you are not in the meeting, because the only evidence, the only full proof we have, it should be on the register, ladies and gentlemen. Thank you very much, colleagues. And Tatin Taute, kindly close this session for us, sir.
Okay, so good morning, colleagues. Good afternoon, colleagues.
Afternoon, Tate.
Uh, Mr. Lamban, I would like to thank you and our colleagues, also examiners, who managed to do this paper for us. Thank you very much, colleagues. With that being said, have a nice day, and then good luck, colleagues. Thank you.
Thank you very much, Ndatin Taute. Ladies and gentlemen, from me to you, thank you very much. May the great Lord bless you and give you everything that your heart desires. With that being said, happy marking and have a lovely weekend. Thank you very much.